Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side CD equals to 2 units, and we also know that CB equals to AD, angle BAD, this angle equals to 30 degrees, angle ABCD, this angle ABC, this angle equals to 90 degrees, and we want to find out the area of this quadrilateral ABCD. So we will start with the first method. In the first method, we will do a construction. We will draw perpendicular from point D to AB. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point D to AB as point E. And we will define line segment DE as A. That is to say, the length of line segment DE is equal to A units. And we will focus on the right triangle, triangle AED. On the right triangle, triangle AED, sinus 30 degrees equals to ED over AD. I repeat again, on the right triangle, triangle AED, sinus 30 degrees equals to ED over AD, but ED equals to A units according to our definition, so we will substitute ED by A. And sinus 30 degrees equals to 1 over 2. So 1 over 2 equals to A over AD. Here we will cross multiply equation number 1, and we will get that AD equals to 2 times A. So we found out that AD equals to 2A. So we can write here that AD equals to 2A. And it is given us the question that AD equals to CB. According to what is given us in the question, we know that AD equals to CB, but we already found out that AD equals to 2A. From this equation, we will derive that CB also equals to 2A. So we can write here that the length of side CB is 2A. CB equals to 2A. In the next step, we will join points D and B together by a straight line. And we will also draw perpendicular from point D to CB. So this angle is a right angle, it equals to 90 degrees. And this angle is also a right angle, it equals to 90 degrees. We will define the touching point between the perpendicular from point D to CB as point F. I present to you a new rule, rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. I'll repeat again in rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So we will focus on quadrilateral DFEB. In quadrilateral DFEB, the sum of the angles must be equal to 360 degrees. And this quadrilateral DFEB has three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 equals to 270 degrees, plus the size of the fourth angle that will define as angle X. The sum of those four angles must be equal to 360 degrees according to rule number 1. So here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees. That is to say, it equals to 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we will substitute angle X by a right angle, as you can see from the drawing, quadrilateral DFEB has four right angles, and we have also rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least the rectangle if not a square. So if not a square, it must be a rectangle. And because of the fact that quadrilateral DFEB has four right angles, we will relate to quadrilateral DFEB as a rectangle. So according to rule number 2, quadrilateral DFEB is a rectangle. It is true according to rule number 2. So we will relate to quadrilateral DFEB as a rectangle, and we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. It means that DE equals to FB in rectangle DFEB. DE must be equal to FB according to rule number 3. But according to our definition, DE equals to A. So here DE equals to A. And from this equation, we will derive that FB also equals to A. FB equals to A. And what is the length of CF? From the drawing you can easily see that CF equals to CB minus FB. I will repeat again. From the drawing, it is very easy to see that CF equals to CB minus FB. CF equals to CB minus FB. So CF equals to CB is 2A minus FB, FB is A, so CF equals to 2A minus A, 2A minus A is A. So we found out that CF equals to A. In the next step, we will prove that a triangle DFB congruent to triangle DFC. Okay, triangle DFB congruent to triangle DFC, this triangle. So why those two triangles congruent to each other? First of all, we know that BF equals to FC equals to A. I will repeat again. We know that BF equals to FC equals to A. We also know that those two angles, they are equal to each other, they are both equal to 90 degrees, so angle DFB, this angle, equals to angle DFC, this angle, and they are equal to 90 degrees. I'll repeat again. Angle DFB equals to angle DFC equals to 90 degrees. And we also have a common side. DF is the common side, it belongs to both triangles. So we can write down that DF equals to itself. DF equals to DF. It's a common side that belongs to both triangles. I'll repeat again, DF equals to DF is the common side that belongs to both triangles. So we actually prove that this triangle DFB, congruent, this is the sign of congruent, to triangle DFC, according to side angle side rule. And repeat again, we actually proved that triangle DFB congruent to triangle DFC according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between them in one triangle congruent to two sides and the angle between them in another triangle, then you prove that those two triangles congruent to each other according to side angle side rule. And we actually proved that those two sides and the angle between them, that is to say this angle in triangle DFB, congruent to those two sides and the angle between them, that is to say this right angle in triangle DFC. Therefore we proved that those two triangles congruent to each other according to side angle side rule. And from the fact that those two sides congruent to each other, we will conclude that CD equals to DB. CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. So right here that CD equals to 2 units. And from this equation, we will derive that dB also equals to 2 units. dB equals to 2 units. Here we can write down that dB equals to 2 units. In the next step, I will present to you a new rule, and we will implement the new rule or the new law in triangle ADB. Okay, so the new law, it is actually the law of cosines. The law of cosines is true in any triangle. So we can write down that in any triangle, so if we have triangle ABC, that could be any triangle, This is triangle ABC. We know that side AB of this triangle is equal to A units in its length. Side BC of triangle ABC equals to B units in its length. And side AC of this triangle equals to C units in its length. And we also know that the angle between side AB and side BC is angle theta. Then, according to the law of cosines, A squared plus B squared minus 2 times A times B times cosine theta equals to C squared. Again, in any triangle, A squared plus B squared minus 2 times A times B times cosine theta equals to C squared. Here we will subtract C squared and then add 2 times AB cosine theta to this equation, and we will get that A squared plus B squared minus C squared equals to 2 times A times B times cosine theta So here we will divide this equation by 2 times AB, and we will get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. So in any triangle, cosine theta equals to A squared plus B squared minus 2 times AB. And in any triangle, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay, so we can implement the law of cosines in our triangle ADB. So I will copy triangle ADB in a new page, and we will implement the law of cosines in this triangle ADB. Okay. So this is triangle ADB that I copied from the original drawing. We know that AD equals to 2A, AB equals to 4 units, and DB equals to 2 units. According to the law of cosines, cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. Okay. So 2a squared is 4a squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, over 2 times 4 is 8, and 8 times 2a is 16a. And we know that cosine 30 degrees is square root of 3 over 2. It equals to 4a squared plus 12 over 16a. Here we will multiply this equation by 16a, and we will get that square root of 3 over 2 times 16a equals to 4a squared plus 12. 16 over 2 is 8, so I write it down. 8 times square root of 3 times a equals to 4a squared plus 12. Here we divide this equation by 4, and we will get that 8 over 4 is 2, so it is 2 times square root of 3 times a equals to 4 over 4 is a, so here we will have a squared plus 12 over 4 is 3. Here we will subtract 2 times square root of 3a from this equation, and we will get that a squared plus 3 minus 2 times square root of 3a equals to 0. We will substitute 3 by square root of 3 squared, because square root of 3 squared equals to 3. We get that a squared plus square root of 3 squared plus 2 times a times square root of 3 equals to 0. Actually, this expression is very similar to the algebraic identity that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to a and b equals to square root of 3 units. So we can substitute our specific expression by a minus b squared, that will be equal to 0, because of the fact that according to this algebraic identity, a squared plus b squared minus 2 times ab equals to a minus b squared. So in our specific expression, a equals to a and b equals to square root of 3, so a minus b squared will be equal to a minus square root of 3 squared, that equals to 0. Here we will take a root out of this equation, and we will get that a minus square root of 3 equals to 0, because of the fact that the square root of 0 is 0. We will add square root of 3 to this equation, and we will get that a equals to square root of 3 units. So we found out that A equals to square root of 3 units. So we can write here that A equals to the square root of 3 units. Here also A equals to square root of 3 units. And we write here that A equals to the square root of 3 units. In the next step, we will focus on the right triangle, triangle DEB. On the right triangle, triangle DEB. In triangle DEB, according to the Pythagoras theorem, here on the right triangle, triangle DEB, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, dB square is the square of the hypotenuse. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to dE square plus EB square. I repeat again. In the right triangle, triangle DEB, according to the Pythagoras theorem, dB square equals to dE square plus EB square. If dB equals to 2 units, so dB square will be equal to 4. And it equals to dE square. dE equals to square root of 3, so square root of 3 square equals to 3. Plus EB square. EB is the missing variable, so we will leave it as it is. Plus EB square. So we found out that according to equation number 1, 4 equals to 3 plus EB square. We will subtract 3 from this equation, equation number 1. And we will get that 4 minus 3 is 1. 1 equals to 3 minus 3 is 0, so 1 equals to EB square. Here we will take a root out of this equation, equation number 1, and we will get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1 unit. Here we can write that EB equals to 1 unit. But because of the fact that according to rule number 3, the opposite sides of a rectangle are equal to each other, in rectangle DFEB, the opposite sides are equal to each other, that is to say EB equals to DF. But EB equals to 1 unit, so DF will be also equal to 1 unit. And what is the length of line segment AE? The length of line segment AE equals to AB minus EB. Again, AB minus EB equals to AE. AE equals to AB minus AE. I'll repeat again, from the drawing it is very easy to see that line segment AE equals to AB minus AE. So AE equals to AB, that is 4 units, minus AE, that is 1 unit. So AE equals to 4 minus 1, that is to say AE equals to 3. 4 minus 1 is 3. So we found out that AE equals to 3 units. Now it is very easy to find out the area of quadrilateral ABCD, because the area of quadrilateral ABCD will be equal to the area of the right triangle, triangle ADE, plus the area of rectangle DFEB, this rectangle, plus the area of the right triangle, triangle CFD, this right triangle. I will repeat again. The area of quadrilateral ABCD will be the sign, the squared brackets is the sign for the area. It means the area of quadrilateral ABCD will be equal to the area of triangle ADE plus the area of rectangle DFEB plus the area of the right triangle, triangle CFD. Okay. What is the area of the right triangle, triangle ADE, this right triangle? The area will be equal to the base of the triangle, that is actually AE, times the height to the base, that is actually ED, over 2. Okay, so the area of the right triangle, triangle ADE equals to AE times AD over 2, and the area of rectangle DFEB will be equal to the width of the rectangle times the length of the rectangle. That is to say, the width of the rectangle is EB, times the length of the rectangle, that is actually ED. Okay, so the area of rectangle DFEB is the width times the length, that is to say EB times ED. And the area of this triangle, triangle CFD, will be equal to the base of the triangle, that is actually DF, times the height to the base, that is actually CF, over 2. So the area of the right triangle, triangle CFD, equals to the base, that is DF, times the height, that is CF, over 2. So what is the value of AE? AE equals to 3 units. What is the value of ED? ED equals to square root of 3 units over 2. So we found out that the area of the right triangle, triangle ADE equals to 3 times square root of 3 over 2. And what is the value of ED? The value of EB? The value of EB equals to 1 unit times ED. ED equals to square root of 3 units. So we found out that the area of rectangle DFEB equals to square root of 3 units. And what is the area of the right triangle CFD? The area of the right triangle CFD equals to DF is 1 unit, plus CF equals to square root of 3 units, over 2. So we found out that the area of the right triangle CFD equals to square root of 3 over 2. So here we will multiply square root of 3 by 2, and then we will divide it by 2 in order to have a common factor with the other two expressions. So we multiply it by 2 and then we will divide it by 2. In the next step, we will take a common factor square root of 3 over 2 out of these three expressions. And we will get that, so square root of 3 over 2 is the common factor that we took from those three expressions. So what is left from this expression after we took from it a common factor of square root of 3 over 2? What is left? It is actually 3. And what is left from this expression after we took from it square root of 3 over 2? What is left? It is actually 2. And what is left from this expression after we took from it square root of 3 over 2? What is left? It is actually 1. One plus 2 is 3, 3 plus 3 is 6, so we will get that square root of 3 over 2 times 6 is the area of quadrilateral ABCD. 6 over 2 is 3 times square root of 3. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. I will repeat again, the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. So we finish with the first method. In the next step, I will present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method, we will do another construction. From point A, we will go perpendicular to AB. So this angle will be equal to 90 degrees. It will be a right angle. And from point C, we will go perpendicular to CB. So this angle will be a right angle. It will be equal to 90 degrees. define the touching point between the perpendicular from point A and the perpendicular from point C as point E. So actually we created here quadrilateral ABCE. In quadrilateral ABCE we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle that we will define as angle X. So the sum of those four angles in quadrilateral ABCE must be equal to 360 degrees according to rule number 1. I'll repeat again. The sum of the angles in quadrilateral ABCE must be equal to 360 degrees according to rule number 1. That is to say, the sum of the three angles, that is actually 270 degrees, plus the size of the fourth angle must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that angle X will be equal to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X is a right angle, that is to say it is equals to 90 degrees, so we'll substitute angle X by a right angle. So, as you can see from the drawing, quadrilateral ABCE is four right angles, and according to rule number 2, any quadrilateral that has four right angles must be at least a rectangle. So we will relate to quadrilateral ABCE as a rectangle. I'll repeat again. According to rule number 2, quadrilateral ABCE is a rectangle because of the fact that it has four right angles. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle ABCE are equal to each other. It means that AB equals to CE. AB equals to CE according to rule number 3. I'll repeat again. AB equals to CE according to rule number 3, that the opposite sides of a rectangle are equal to each other. But it is given us in the question that AB equals to 4 units. So we can write here that AB equals to 4 units. And from this equation, we will derive that CE also equals to 4 units. Here, CE equals to 4 units. Likewise, according to rule number 3, CB equals to AE. CB equals to AE. according to rule number 3. If we define CB as x, that is to say CB equals to x, here CB equals to x according to our definition, from this equation we will derive that AE also equals to x, AE equals to x, so we can write here that AE equals to x. It is given us in the question that CB equals to AD, CB equals to AD, it is given us in the question, but according to our definition, CB equals to x. CB equals to x according to our definition. From this equation, we will derive that AD also equals to x. AD equals to x. And what is the value of angle DAE? The value of angle DAE will be equal to 90 degrees minus 30 degrees. You can see easily that the value of angle EAD equals to 90 degrees minus 30 degrees. That is to say, the value of angle DAE equals to 60 degrees. In the next step, we will join points E and D together by a straight line. And we will join points D and B together by a straight line. I will copy triangle AD in a new page and we will analyze triangle AD. Okay. So this is triangle AD that I copied from the original image. We know that AE equals to AD, AE equals to AD equals to X, and then again DAE equals to 60 degrees. Here we know that AE equals to AD, and we also know that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides there are equal angles. That is to say, those two angles that are located in front, the equal sides must be equal to each other. So if we define this angle as y, then this angle must be also equal to y. And we know that the sum of the angles in any triangle is equal to 180 degrees, so the sum of the angles in triangle AD must be equal to 180 degrees. That is to say, y plus 60 degrees must be equal to 180 degrees. Y is 2y plus 60 degrees equals to 180 degrees. We will subtract 60 degrees from this equation and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We will divide this equation by 2 and we will get that angle y equals to 180 degrees over 2 is 60 degrees. So we found out that angle y equals to 60 degrees. So we substitute y by 60 degrees. Here also y equals to 60 degrees. So actually we found out that triangle AED is an equilateral triangle. Triangle AED is an equilateral triangle. And we know that in an equilateral triangle all the sides are equal to each other, so if AE and AD equals to x, then ED must be also equal to x. So in the original drawing, we can write down that ED equals to x, this angle equals to 60 degrees, and this angle also equals to 60 degrees. And what is the value of angle CED, this angle? This angle will be equal to 90 degrees, angle AED minus 60 degrees. That is to say, angle CED will be equal to 30 degrees. In the next step, we will prove the triangle triangle ADB can go into triangle ADC. Okay, we will prove that triangle ADB can go into triangle ECD. So why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. I'll repeat again. AB equals to EC equals to 4 units. We also know that those two angles are equal to each other, they are both equal to 30 degrees, so we can write down that angle BAD, this angle equals to this angle that is actually angle DEC, and they are both equal to 30 degrees. I'll repeat again. Angle BAD equals to angle DEC equals to 30 degrees. And we also know that AD equals to ED equals to x. AD equals to ED equals to x. I'll repeat again. AD equals to ED equals to x. So we actually proved that this triangle ADB can go into this triangle EDC, according to side rule. repeat again. We prove that triangle ADB can go into triangle EDC according to side against side rule. We actually proved that those two sides and the angle between them in triangle ADB can go into those two sides and the angle between them in triangle EDC. Therefore, we proved that those two triangles can go into each other according to side against side rule. And from the fact that those two triangles can go into each other, we will conclude that CD equals to DB. CD equals to DB. And actually, CD equals to DB according to the rule that corresponding sides it can go in triangles. It can go in triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. So we can write down that here CD equals to 2 units. And from this equation, we will derive that DB also equals to 2 units. DB equals to 2 units. Here DB equals to 2 units. So in the next step, we will implement the law of cosines in triangle ADB. So I will copy triangle ADB in a new page and we will implement the law of cosines in this triangle, triangle ADB. So this is triangle ADB that I copied from the original drawing. And according to the law of cosines, we will get that cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4 cosine 30 degrees is square root of 3 over 2 and it will be equal to x squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, over 2 times 4 is 8, 8 times x is 8x. Here we will multiply this equation by 8x and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. Here 8 over 2 is 4. So we write down that 4 times square root of 3x equals to x squared plus 12. Here we subtract 4 times square root of 3x from this equation and we will get that x squared plus 12 minus 4 times square root of 3x equals to 0. We know that 12 is 2 times square root of 3 squared, so we will substitute 12 by 2 times square root of 3 squared and we will get that x squared plus 2 times square root of 3 squared, that is 12, minus we will substitute 4 by 2 times 2, so we will get that it is minus 2 times x times 2 times square root of 3, that equals to 0. Actually, this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3 units. So we can substitute our expression by a minus b squared according to this algebraic identity. In our specific expression, a minus b squared means a is x, so it is x, minus b is 2 times square root of 4, so it is b is 2 times square root of 3, so it is minus b minus 2 times square root of 3 square, that equals to 0. Here we will take a root out of this expression and we will get that x minus 2 times square root of 3 equals to 0. Because of the fact that the square root of 0 is 0, we will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So we found out that x equals to 2 times square root of 3 units, so we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. Here x equals to 2 times square root of 3 units. And here also x equals to 2 times square root of 3 units. So now we can find out the area of triangle, the area of quadrilateral ABCD, because the area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle CDB. What is the area of triangle ADB? The area of triangle ADB, first of all, we will find out the height of triangle ADB. So from point D, we will draw perpendicular to AB. So this angle, it is a right angle. This angle, it is also a right angle. We will define the touching point between the perpendicular from D to AB as point S. We will define line segment SD as H. We will focus on triangle ADB, triangle ADS, on the right triangle, triangle ADS. Here, on triangle ADS, sinus 30 degrees equals to H over 2 times square root of 3 . I'll repeat again. In triangle ADS, sinus 30 degrees equals to H over 2 times square root of 3. We know that sinus 30 degrees equals to 1 over 2, so I'll write it down. We get that 1 over 2 equals to H over 2 times square root of 3. Here we will multiply this equation by 2 times square root of 3. And we will get that H equals to 2 times square root of 3 over 2 2 over 2 is 1, so we found out that h equals to square root of 3 units. Here, h equals to square root of 3 units. So now it is very easy to find out the area of triangle ADS, of triangle ADB, and before that the area of quadrilateral ABCD will be equal to the area of triangle ADB, this triangle, plus the area of triangle DCB. I'll repeat again, the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DCB. And the area of triangle ADB equals to the base of the triangle that is actually AB times the height to the base that is actually H over 2. I'll repeat again, the area of triangle ADB equals to the base AB times the height that is H over 2 here AB equals to 4, H equals to square root of 3 over 2. So we actually found out that the area of triangle ADB equals to 4 over 2 times square root of 3 units. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 square units. The only thing that is left to do is to find out the area of triangle DCB. Okay, the area of this triangle, we will find out the area of triangle DCB according to a special formula. The semi-perimeter of any triangle equals to the perimeter over 2. The perimeter of this triangle, triangle DCB, equals to 2 plus 2 plus 2 times square root of 3 units. So I'll write it down. So the perimeter of triangle DCB is 2 plus 2 plus 2 times square root of 3. The perimeter of triangle DCB equals to the sum of its sides, that is to say 2 plus 2 plus square root 2 plus 2 plus 2 times square root of 3. And if we divide the perimeter by 2, we will get the semi-perimeter. S is the semi-perimeter, so we will divide the perimeter by 2, and we will get the semi-perimeter. S is abbreviation for semi-perimeter. So the semi-perimeter of triangle DCB equals to 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2. 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DCB equals to 2 plus square root of 3 units. and the area of triangle DCB will be equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter that is actually 2 plus square root of 3 units. A, B and C is the side lengths of triangle ABC, of triangle DCB. We know that A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 3 units. So we will get that the area of triangle DCB equals to the square root of S is 2 plus square root of 3, S minus A is 2 plus square root of 3 minus 2 is square root of 3, S minus B is the same because A, the same result because A equals to B, so it is also square root of 3, and S minus C is 2 plus square root of 3 minus 2 times square root of 3, that is to say it equals to 2 minus square root of 3, so it will be equal to square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3, we will calculate this expression according to the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A equals to 2, so A squared will be equal to 2 squared, 2 squared is 4. B equals to square root of 3, so B squared will be equal to square root of 3 squared, square root of 3 squared is 3. So we got here 4 minus 3. 4 minus 3 is 1. 1 times 3 is 3. So we found out that the area of triangle DCB equals to the square root of 3 units. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ADB plus the area of triangle DCB and we already found out that the area of triangle ADB is 2 times square root of 3 square units, and the area of triangle DCB equals to 1 times square root of 3 units. 2 times square root of 3 units times 1 times square root of 3 units equals to 3 times square root of 3 units. So we found out that the area of triangle, the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay. So in the next step I will summarize the lecture. Actually we wanted to find out the area of this quadrilateral ABCD, and we found the area of quadrilateral ABCD in 2 different methods. In the first method, we did a construction from point D From point D we draw perpendicular to AB. So this angle is 90 degrees, this angle is 90 degrees. We define the touching point between the perpendicular from point D to AB as point E. Then we defined line segment ED as A. Then we focus on triangle ADE. On the right triangle, triangle ADE. We can write down that sine 30 degrees equals to DE over AD. Here, in triangle AD, sine 30 degrees equals to ED over AD. But ED equals to A according to our definition. So we substituted ED by A. So it is sine 30 degrees equals to A over AD. And sine 30 degrees equals to 1 over 2. So we get that 1 over 2 equals to A over AD. We cross multiply this equation number 1, and we got that AD equals to 2A. So we can write here that AD equals to 2A. But AD equals to CB according to what is given us in the question. From one side AD equals to CB according to what is given us in the question, and from the other side we found out that AD equals to 2A. So from this equation we will derive that CB also equals to 2A. Okay, CB equals to 2A, so we can write here that CB, the length of CB, it is actually equal to 2A. Then I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So if we focus on this quadrilateral DFEB, actually before that, from point D we draw perpendicular to CB. We define the touching point between the perpendicular from D to CB as point F. So we created in this way quadrilateral DFEB. In quadrilateral DFEB we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 90 times 3 equals to 270 degrees, plus the size of the 4th angle must be equal to 360 degrees according to rule number 1. Okay, quadrilateral DFEB, 270 degrees plus the size of angle X must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation and we got that angle X equals to 90 degrees. Then I presented to you rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. If quadrilateral DFEB has 4 right angles, therefore according to rule number 2, quadrilateral DFEB is a rectangle. Okay, quadrilateral DFEB is a rectangle. Then I presented to you rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. It means that DE equals to FB. According to rule number 3, DE equals to FB, but DE equals to A according to our definition. From this equation we will derive that FB also equals to 2 units. FB also, from this equation we will derive that FB equals to A. Okay, FB equals to A. Here FB equals to A. So what is the value of line segment CF? CF will be equal to CB minus FB. CF equals to CB minus FB. And CB equals to 2A and FB equals to A. Therefore CF will be equal to 2A minus A. 2A minus A is A. So we found out that CF equals to A. Then we actually proved that those two triangles can go into each other. Triangle DFB can go into triangle DFC. Why they can go into each other? First of all, BF equals to FC equals to A. We know that BF equals to FC equals to A. We also know that those two angles are equal to each other, they are both equal to 90 degrees, so angle DB equals to angle DC equals to 90 degrees. Okay, and we also have a common side. DF is a common side, it belongs to both triangles, so DF equals to itself. It's a common side that belongs to both triangles. So we proved the triangle DFB can go into triangle DFC according to side angle side rule. Okay, what is side angle side rule? If we prove that two angles in two sides and the angle between those two sides in one triangle can go into two sides and the angle between those two sides in another triangle, then you proved that those two triangles can go into each other according to side angle side rule. And we proved that those two sides and the angle between those two sides, that is to say this right angle triangle DCF can go into those two sides and the angle between those two sides, that is to say this right angle is triangle DFB. Therefore we proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will derive that CB equals to DB. That CD equals to DB. CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say DC and DB, will be equal to each other. Okay, DC equals to DB, but it is given us in the question that DC equals to 2 units. So from this equation, we will derive that dB also equals to 2 units. dB equals to 2 units. Then I presented to you the law of cosines, and we implemented the law of cosines in triangle ADB. What is the law of cosines? The law of cosines is true in any triangle. So in any triangle, if you know that side AB equals to A units, side AC equals to C units, side BC equals to B units, then according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. Here we subtracted C squared and added 2 times AB cosine theta to this equation, and we got that 2 times AB, we got that A squared plus B squared minus C squared equals to 2 times AB. We divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB, and we can use this equation in any triangle. Then we implemented the law of cosines in triangle DAB, so I copied triangle DAB in this new page and implemented the law of cosines in this triangle. According to the law of cosines, cosine 30 degrees will be equal to 2a squared plus 4 squared minus 2 squared over 2 times 2a times 4. So cosine 30 degrees is square root of 3 over 2. 2a squared is 4a squared, 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, 2 times 4 is 8, 8 times 2a is 16a. So in conclusion, we got that the square root of 3 over 2 equals to 4a squared plus 12 over 16a. We multiply this equation by 16a, and we got that square root of 3 over 2 times 16a equals to 4a squared plus 12. 16 over 2 is 8, so we got that 8 times square root of 3 times a equals to 4a squared plus 12. We divided this equation by 4, and we got that 8 over 4 is 2, so in this side of the equation we have 2 times square root of 3 times a equals to 4 over 4 is 1, so we got here a squared, and 12 over 4 is 3, so in conclusion we got that 2 times square root of 3 times a equals to a squared plus 3. Here we subtracted 2 times square root of a from this equation, and we got that a squared plus 3 minus 2 times square root of 3 times a equals to 0. Here we substituted 3 by square root of 3 squared, and we got that a squared plus square root of 3 squared minus 2 times minus 2 times a times square root of 3 equals to 0. This expression is very similar to the algebraic identity that says that a squared plus b squared minus 2 times ab equals to a minus b squared that equals to 0. So we can substitute this expression by a minus b squared that equals to 0. In our specific expression, a equals to a and b equals to square root of 3. And a minus b squared will be equal to a minus square root of 3 squared that equals to 0. We took a root off to this equation and we got that the square root of 0 is 0. So we got that a minus square root of 3 equals to 0. We added the square root of 3 to this equation and we found out that a equals to square root of 3 units. So we can write here that a equals to square root of 3 units. Here also a equals to square root of 3 units. And here also a equals to square root of 3 units. Then we focused on the right triangle, triangle DEB. We implemented the Pythagoras theorem on this right triangle, triangle DEB. According to the Pythagoras theorem, dB square equals to DE square plus EB square. dB equals to 2, so dB square is 2 square, 2 square is 4, plus and it equals to DE square. D is square root of 3, so DE square is square root of 3 square is 3, plus EB square. So 4 equals to 3 plus EB square. We subtracted 3 from this equation, equation number 1, and we got that 4 minus 3 is 1. So we got that 1 equals to EB square. We took a root out of this equation and we got that EB equals to the square root of 1 is 1. So we found out that EB equals to 1 unit, and because of the fact that the opposite sides of a rectangle are equal to each other, DF will be also equal to 1. And then what is the value of AE? AE equals to AB minus EB. AE equals to AB minus EB. AB equals to 4 units. AE equals to 1. So AE equals to 4 minus 1. That is to say AE equals to 3 units. Then we found out the area of quadrilateral ABCD. It equals to the area of the right triangle ADE plus the area of rectangle DFEB plus the area of triangle DCF. The area of triangle ADE equals to the base of the triangle that is DE times the height to the base that is DE over 2. The area of rectangle DFEB equals to EB times ED. And the area of triangle CFD equals to the base of the triangle that is DF times the height to the base that is CF over 2. And AE equals to 3, ED equals to square root of 3, all divided by 2. So the area of triangle ADE equals to 3 times square root of 3 over 2. The area of rectangle DFEB equals to EB times ED over 2. EB is 1, ED is square root of 3. So the area of rectangle DFEB equals to square root of 3 square units. And the area of triangle CFD equals to DF times CF over 2. DF is 1, CF is square root of 3, all divided by 2. So the area of triangle CFD equals to square root of 3 over 2 square units. Then we multiplied square root of 4 by 2 and then we divided by 2 in order to have a common factor of the other two expressions. We took a common factor of square root of 3 over 2 from this, out of these three expressions. Inside the brackets we left from this expression 3, from this expression 2, and from this expression 1. So square root of 3 over 2 times 3 plus 2 is 5, 5 plus 1 is 6, and 6 over 2 is 3. So in conclusion we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers it equals to 5.196 square units. We finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD according to the second method. In the second method, we did another construction. From point A, here. From point C we drew perpendicular, from point C we drew perpendicular to BC, so this angle is 90 degrees. And from point D, from point A, we draw perpendicular to AB, so this angle will be also equal to 90 degrees, and we define the touching point between the perpendicular from point A and the perpendicular from point C as point E. Actually, we created here quadrilateral ABCE. Quadrilateral ABCE is 3 right angles. We define this angle as X, and we note that the sum of the angles in any quadrilateral is equal to 360 degrees. That is to say, the sum of 3 angles, that is 270 degrees, plus the size of the fourth angle, that is angle X, must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that angle X equals to 90 degrees. So quadrilateral ABCE is 4 right angles, therefore, according to rule number 2, quadrilateral ABCE is a rectangle. And we know, according to rule number 3, that the opposite sides of a rectangle are equal to each other, that is to say AB equals to CE. AB equals to CE, but it is given as the equation that AB equals to 4. From this equation we will derive that CE also equals to 4. Here CE equals to 4. Likewise, AE equals to CB according to rule number 3. AE equals to CB according to rule number 3. We define CB as X, therefore from this equation we will derive that AE also equals to X, so CB equals to X, AE also equals to X. And according to what is given us in the question, CB equals to AD. But we already know that CB equals to X, so from this equation we will derive that AD also equals to X. Here AD also equals to X. Then we join points E and D together by a straight line, and we join points D and B together by a straight line. And then we know that this angle is a right angle, this angle equals to 40 degrees, so 90 degrees minus 40 degrees is the value of this angle. So I copied triangle AED in a new page, and we analyze triangle AD. In triangle AD, we know that EA equals to AD equals to X, this angle equals to 60 degrees, and we know that in front of equal sides in the triangle there are equal angles, so those two angles must be equal to each other. If this angle is Y, then the other angle must be also equal to Y. So we know that the sum of the angles in any triangle is equal to 180 degrees, that is to say Y plus 60 degrees equals to 180 degrees in triangle ADE. Y plus Y is 2Y, 2Y plus 60 degrees is 180 degrees. We subtracted 60 degrees from this equation, and we got that 2Y equals to 180 degrees minus 180 degrees minus 60 degrees is equals to 120, 180 degrees minus 60 degrees is equals to 120 degrees. We divided this equation by 2, and we got that Y equals to 180 degrees over 2, that is to say angle Y equals to 60 degrees. So this angle equals to 60 degrees, and this angle also equals to 60 degrees. So we found out that triangle AD is an equilateral triangle, and we know that all the sides of the equilateral triangle are equal to each other, so ED must be also equal to X. So here we can write down that ED equals to X, and this angle is 60 degrees, and this angle is also 60 degrees. But here we know that angle AEC equals to 90 degrees. So 90 degrees minus this angle that is 60 degrees must be equal to this angle. So angle DEC must be equal to 30 degrees. Then we prove that those two triangles can go into each other. Why those two triangles can go into each other? Triangle ADB can go into triangle ECD. Why? Because first of all we know that AB equals to CE equals to 4 units. AB equals to CE equals to 4 units. We know that those two angles are equal to each other, they are both equal to 30 degrees. angle BAD equals to angle DEC equals to 30 degrees. And we also know that AD equals to DE equals to X. AD equals to ED equals to X. So we proved that triangle ADB congruent to triangle ADC according to side angle side rule. And from the fact that those two triangles congruent to each other, we will derive that CB equals to CD equals to DB. CD equals to DB according to the rule that corresponding sides and congruent triangles are equal to each other. But we know that CD equals to 2 units according to what is given us in the question. From this equation we will derive that DB also equals to 2 units, DB equals to 2 units. Then I copied triangle ADB in a new page and we implemented the law of cosines in triangle ADB. So this is triangle ADB. According to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. Cosine 30 degrees is square root of 3 over 2. X squared plus 4 squared is 16 minus 2 squared is 4. 16 minus 4 is 12. So in the denominator we have x squared plus 12. And in the numerator we have x squared plus 12. And in the denominator we have 2 times 4 is 8. And 8 times x is 8x. So in conclusion, the square root of 3 over 2 equals to x squared plus 12 over x, 8x. We multiplied this equation by 8x and we got that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4. So in this side of the equation we have 4 times square root of 3 times x equals to x squared plus 12. And then we subtracted 4 times square root of 3x from this equation and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. We know that 12 is 2 times square root of 3 squared, so we substituted 12 by 2 times square root of 3 squared, and we got that x squared plus 2 times square root of 3 squared minus 2x times 2 times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. In our specific expression, a equals to x and b equals to 2 times square root of 3, so a minus b squared that equals to 0. In our specific quadratic equation, it means that x minus 2 times square root of 3 squared equals to 0. We took out of this equation and we found out that x minus 2 times square root of 3 equals to 0. We added 2 times square root of 3 to this equation and we found out that x is equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. And here also x equals to 2 times square root of 3 units. Then we calculated the height of triangle ADB. We draw perpendicular to AB. We define the touching point between the perpendicular from D to AB as point S. We define side segment DS as H. In triangle ADS, we know that sinus 30 degrees equals to H over 2 times square root of 3 units. Again, in triangle ADS, sinus 30 degrees equals to H over 2 times square root of 3 units. Sinus 30 degrees is 1 over 2, so we found out that 1 over 2 equals to H over 2 times square root of 3 units. We multiplied this equation by 2 times square root of 3 units and we found out that H equals to 2 times square root of 3 over 2. 2 over 2 is 1, so H equals to square root of 3 units. So we found out that H equals to square root of 3 units. Now the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DCB. The area of triangle ADB equals to the base of the triangle that is AB times the height that is H over 2. AB equals to 4, H equals to square root of 3. So the area of triangle ADB equals to 4 times square root of 3 over 2. That is to say 4 over 2 is 2. So we found out that the area of triangle ADB equals to 2 times square root of 3 square units. Then we found out that area of triangle DCB, the area of triangle DCB first of all, the semi-perimeter of any triangle equals to the perimeter over 2, and the perimeter of triangle DCB is 2 plus 2 plus 2 times square root of 3, 2 plus 2 plus 2 times square root of 4 to 3. If we divide the perimeter by 2, we will get the semi-perimeter. So the semi-perimeter of triangle DCB is 2 plus 2 is 4, plus 2 times square root of 3 over 2. So the semi-perimeter of triangle DCB equals to 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DCB equals to 2 plus square root of 3 units, and the area of triangle DCB equals to the square root of s times s minus a times s minus b times s minus c. S is the semi-perimeter, A and B and C are the lengths of triangle DCB sides. And we know that A equals to 2, B equals to 2, and C equals to 2 times square root of 3. So S is 2 plus square root of 3. S minus A is square root of 3. S minus B is square root of 3. And S minus C is 2 minus square root of 3. Square root of 3 times square root of 3 is 3. So what is left inside the root is 2 plus square root of 3 times 2 minus square root of 3. We calculated this expression according to the algebraic identity that a plus b times a minus b equals to a square minus b square. Here a equals to 2, so a square is 2 squared, 2 squared is 4. B equals to square root of 3, so b square is square root of 3 squared, that is 3. So we got here 4 minus 3 is 1, 1 times 3 is 3. So we got that the area of triangle BCD equals to square root of 3 square units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DCB. The area of triangle ADB is 2 times square root of 3 units, and the area of triangle BCD is 1 times square root of 3 units. So 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we found out in both methods that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. Okay? Thank you very much.